I'm so excited about this one. I want to get right into it real quick. So, sometimes blueprints are just the better choice for getting things done. For example, defining our door swing as a visual curve is the ideal way to do it, rather than messing around with sine waves and things in code. So we can create an event called onOpenRequest, and we can declare it as blueprint assignable uProperty, but only according to these documentations, but only if we do some cool things. So let's dive in and see how it's done. So now with our nicely protected code in hand, it's time to do something pretty cool. What I'd like to do is, rather than these doors just opening perfectly to 90 degrees instantly like that, what I want to do is use something called a node editor in Blueprint. So the first thing we're going to need is some blueprints to work on, and that's going to be a blueprint of the doors themselves. So if we look at these doors right now, then they are a compound object with an open door component on them, and the same door is being used in more than one place. So this is an instance where we want to be making a blueprint of the door. So let's start by doing that. Click on either door, go to the Blueprints menu, and carefully choose the Convert Selected Actor, not components, actor to Blueprint class. Let's do that. I'm going to call it Openable Door, maybe with an underscore, because that was the pattern they were using, and create blueprint. Cool. Now, just real quick before I go any further, I'm going to click on the door itself in the viewport, check that the mesh still has a collider on it. It does. That's cool. I've had a problem with that in the past. Okay, so this is it. We actually have a blueprint of the door now. This we can be using to create other similar openable doors. And what we're going to do shortly is we're going to have some events here in the event graph. I'm actually going to delete all this stuff. You're welcome to do that now if you like. Highlight everything in the event graph and just hit your delete key. So we will have an event come in here that says, hey, there's been a door opened. It's going to come from C++. And then we're going to use Blueprint with something called a timeline. Here you go, a timeline at the bottom here. And this timeline is going to allow us to do something pretty cool. It's going to allow us to actually define the movement of the door. Don't bother doing any of this. I'm just going to show you using things called Bezier curves. Look at this. How cool is this? And we're actually going to define the movement like this. This is why we're doing it here in Blueprint. This is a better way of doing things, right? Obviously a better way of doing things than trying to write code to follow those lines. So I'm going to leave an empty graph, and I'm just going to compile my blueprint. All we've done with the openable door as a recap is nothing. We've just made a blueprint. I did just check in the viewport that my mesh has a collider, this purple thing around the outside of it, this collision that's flashing on and off. But I've basically done nothing apart from made a blueprint. Okay, so the left-hand door, if we look in the world outliner, is a blueprinted door. The right-hand one is not. So I'm going to change my other door for a blueprinted door. Going to grab it from there, pop it in the hole. And of course, if it doesn't fit precisely, I may need to change my snap value to just make it fit snugly. Okay, let's try this. Play. Now I get two errors, open door BP and BP264. I can eject with F8. Are missing pressure plates, but we didn't crash because of the work we've just done. Awesome. If I look in my world outliner, I'll find that these are the two doors in question. If you hover over them, door BP, door BP264, the two doors are both missing the pressure plate. That was the problem with the blueprint. We can't, of course, refer to the pressure plate in the blueprint, or we could, but it's not a very reusable asset then. So we're probably better off just getting that error, going to the open door and going, oh yeah, this door's opened by that plate, and this door is also, in this case, and in your game it might be different, I hope you're doing something different, is opened by that one. Cool, so we have a templated door that we can use, and it is stable. If we don't have a trigger volume, the game doesn't crash, we can put it in, and now we're back kind of to where we were, except that we now, with these doors, have a blueprint we can edit. Question is, how do we know when the door's going to open? What we need to do is create an event that's raised in the C++ that we can see in the blueprint. Now, it turns out that's not completely trivial to do, but it's doable. This is the documentation you need. It's linked in the original slide. You need to do this. We need to start by making something blueprint assignable. We're going to make a variable blueprint assignable per here. Okay, so that's a template of it, and this is the example. And to make it blueprint assignable, we need to do this at the top above our class. We're actually going to make a class called F, in our case, on open request. And we're not going to have any other parameters. So we're going to make a new class using this strange method here, this strange macro here. And then we're going to define something, an event handler of type that class, and then we're going to actually get hold of that in Blueprint. So let's go and do it. This is one of these things I've just got to show you how to do, but you're going to get a chance to fiddle with the Blueprint in a minute. So with this pattern in mind, I think I'm just going to copy declared dynamic multicast delegate because that's the thing I'm most likely to spell wrong. Let's go into the IDE and make this happen. So we're going to be in OpenDoor, which makes sense, right? Because it's the OpenDoor.h that we're wanting to extend. Above the class in OpenDoor, I want you to put declare dynamic multicast delegate. That's a mouthful, isn't it? Why do we need this? Let's not go into too much detail. Basically, if we want to make an event blueprint assignable, it basically needs to be one of these guys. It turns out that an event is a special part or a subset, if you like, of a dynamic multicast delegate. But look, man, that's a horrible sounding thing, but we are declaring something that is dynamic, which means it's serializable, which we turn out to need, which is multicast, which means one-to-many. And it is a delegate, which means that something else is going to handle the operation, and the something else is going to be the blueprint. That's basically what that means. So, declare dynamic multicast delegate, and then we're going to call it, starting with F, because the Unreal Coding Standard is other classes start with F, on open request. Now, I'm going to start ending all macros with a semicolon unless otherwise stated, just to remove confusion. So let's just make sure this works first. The IDE doesn't like it, Visual Studio doesn't like it, that's because it doesn't understand about these things. What we need to do is go and compile over here, and very much want you to get in the habit of compiling in Unreal because the errors you'll get will be much more useful over here. And it should compile just fine. What we're just doing is proving that that made sense to the compiler one step at a time. Okay, now we want to make a public property, but it's a U property, which we usually use to expose things to the Details tab, and we're going to make it Blueprint assignable. Okay, not this thing it's autofilling, but that does prove it's spelt right. You can choose that if you like, and then take the CPF off the front. So it's a Blueprint assignable thing, and what is it going to be called? Well, the type is going to be this F on open request. You see this has actually gone the right color now that Unreal has had a chance to run. Okay, so we've made a new class. That's why it's above the class definition. This makes a whole new class called F on open request, a new type. So we're going to make an F on open request, and what are we going to call it? What do we always call things when we're not sure? Just the thing without the prefix, on open request. Okay, so this is our thing that is actually going to allow us to handle the event on open request. When's it going to be called, and how do we call it? Well, you don't call an event, you broadcast on an event. So over here in our OpenDoor, let's look at OpenDoor. Let's stop rotating the actor. You can comment it or delete it. I'll comment it for now. And we're just going to say on open event, or request rather, dot, and it's a request because it's the blueprint that's actually going to do the opening, so we're only requesting an opening, dot broadcast. I shouldn't have gone off there, dot broadcast. And that's a method. Okay, so what on earth have we done here? We have made a class. We have said that we want it to be blueprint assignable. We've made this on open request. And then when we open the door, instead of setting the rotation directly, we are broadcasting on that event. Now, let's go and compile and see how in Blueprint we actually get hold of this event. This is a triumph, by the way, in your progress in Unreal. If we can dive and dance between Blueprint and C++ as we need to, we're in a great place, right? We use the tool that's best for the job in hand. C++ has been best up to now. Defining the movement of that door is better in Blueprint. Let's go from C++ to Blueprint, and later I'll show you how to go the other way back. So let's open the door Blueprint. Click on the OpenDoor component. If you're not on the OpenDoor component like this and you right-click inside the event graph, you're not going to get the references you need. The way the Blueprint editor works is you have to be clicked on the thing you want to reference to. Now, with OpenDoor clicked, which is where we just wrote our code, right-click, and you'll see you have Add Event for OpenDoor, Event Dispatchers, Add on Open Request. Zoom in with a mouse wheel, and that is the event. Okay? Awesome. You can drag the execution, the white execution line off the event, set actor rotation, So I want you to drag off the white line. In the thing that comes up, I want you to search for set actor rotation, then choose it. Now your challenge comes. It's very simple, but it gives you a chance to catch up because this has come hard and fast, and to make the final bit, which will be very satisfying. I want you to set a rotation and test it works. Set a door rotation here in the blueprint, test the game still plays the same, and celebrate the fact you're now using C++ events in Blueprint. You may say, how do I set that rotation? Just take a look in the blueprint there. There's 3 numbers for X, Y, and Z. Just choose the correct axis and put a number of degrees in it. You can do it. So welcome back. Let's do this. I'm going to choose minus 60 in Z. Okay, and I'm going to compile my blueprint, play the game. What happens? Nothing. We get on here. It opens. Now, was that because of the blueprint, or is it an illusion? Let's test. Let's go and change that to, I don't know, 30, plus 30. It should come 30 degrees towards me now. Let's see. You see, I have control in Blueprint. That is seriously awesome. Okay, so congratulations. This is really big news. You can now go from C++ to Blueprint via asynchronous events, i.e. events that happen at no particular time. I'm going to make it a minus 80 degree opening. And up next, we're going to talk about how to turn this into a smooth and fluid movement based on a curve that we define in a graphical interface, exactly where we want to be for that job. Well done.